Lesson 8.3.11, Pennies and Quarters, using linear relationships to solve problems. In this lesson, you'll find solutions to linear equations given either the x value or the y value. This is our last lesson in this unit on linear relationships. We're on page 144 to finish up. So here we're going to find solutions to linear equations. Given either the x value or the y value. I feel like we had a little preview of this in the last section, so it should look a little familiar. So no matter the form of a linear equation, we can always find solutions to the equation by starting with one value and then solving for the other value. So we're going to think about this relationship right here, this linear equation. And we're going to find some solutions. And the solutions we're going to find in this example are actually going to be the y-intercept of the line and the x-intercept of the line. And we can find those by plugging in a really simple number. Let me see here. So, like we've done before, I'm going to start by just rewriting this. 2x minus 4y equals 12. And what they're saying is that to find solutions to that equation, I can choose any value I want for one of the variables and then solve for the other variable. And often the easiest number to choose for one of the variables is 0. So if I'm going to just choose x equals 0, again, you can choose anything you want. Let me rewrite this equation and just substitute in 0 wherever I see x. Now I'm trying to find y now. So that step was just substituting. Let me simplify this a little bit. 2 times 0 is just 0. I'm not even going to write it here. Minus 4y equals 12. And to solve this equation, I'm just going to divide by whatever's multiplied to y. Now I know this looks like minus 4, but it's not. It's a negative 4 at this point. I'm going to divide both sides of this equation by negative 4, and that'll give me the number that I'd be able to multiply by negative 4 in order to get 12. So 12 divided by negative 4 is negative 3. And let's take a look at what I've really found here. They asked me to find the y-intercept. If I were to graph this line, it would cross the y-axis at negative 3. But I'm going to jump down here to this next part where it says, based on your work, what are the coordinates of this point that I just found? Well, I chose an x value of 0, and I came out with a y value of negative 3. So that comes together as a coordinate, where x is 0 and y is negative 3. This is what we chose for x. And when we plugged it into the equation, this is what we got for y. That's what we solved for. All right, let's do it again. This time we're going to find the x-intercept. I'll show you the graph in just a moment, and I think the x and y-intercepts are going to make a little more sense. We're going to find the x-intercept of the graph of this equation by substituting in y equals 0. All right, well, like we've been doing, let's rewrite the original equation first. That equation from up here. And this time I'm going to substitute a number in for y. I can choose either variable to substitute any number I want in for. All right, so we're going to start with one value and solve for the other. So 2x minus 4, And I've chosen 0 for y this time. 0 is such a wonderful number to substitute in because it just makes a term disappear. So when I simplify this a little bit, I end up with 2x minus 4 times 0 is just 0, so I'm not even going to write that. 2x equals 12. So I have to ask myself, what can I multiply by 2 to get 12? And to solve this equation, I can just divide both sides by 2. 12 divided by 2 is 6. So they asked me to find the x-intercept of this line, and this line's going to cross the x-axis at 6. Again, let me come down here to the next section that says, based on your work above, what are the coordinates of this point that I just found? Well, let's remember that this time I chose a y value. I chose to make y equal to 0. So as a coordinate, this is where y would be. I wanted y to be 0 this time. That's what I chose. And when I chose that and solved for x, this is what I got for x. And what this little section is reminding us of is that both of these are solutions to the equation we started with. The equation 2x minus 4y equals 12. I want to show you the graph of the equation that we've been working with, partly to reinforce what we learned in the last lesson, that solutions appear on the graph. I don't know where to put this. I'll put it right here. So if I were to graph 2x minus 4y equals 12, it would look like this. And you can see that the points that we found that were solutions to this are actually points that are on this line. The point 0,3 was a solution, and the point 60 was a solution, and they appear on this line. So once you've identified one solution to your equation, what are some ways you can find others? Well, if you'd like, you can just continue substituting values for one variable and finding or solving for the other. Continue substituting values for one variable and solving for the other. You just have to keep track of what you substituted in, because that's going to be one of the numbers in your coordinate. Or you can graph the line and identify other coordinates or points on the line. Put or. Graph the line and identify other points on the line. So that's how we can find solutions to linear equations if we are given or we choose an x value or a y value.